It's been called terra incognita, the unknown land. A vast maze of islands, inlets, and peninsulas that populate a mostly frozen sea. It is largely treeless, its ground mostly frozen, and during its sunless winters becomes one of the coldest places on the planet. This polar region at the top of the Earth is known today as the Arctic. Its vast, unspoiled environment is inhabited by unique wildlife, adapted to the extreme conditions that rely on ice to survive. To Western nations, the Arctic was one of the globe's few remaining blank spaces, the last great unnavigated, unmapped frontiers, isolated and protected by its ice. Now a warming climate is profoundly changing this frozen world. In the summer of 2019, the Northwest Passage Project ventures into the Canadian Arctic Archipelago on an 18-day expedition aboard the Swedish ice-breaking research vessel, Oden. For centuries, sailors were obsessed with finding a path across the mostly frozen Arctic. Now, scientists are racing to understand a melting Arctic and how these changes will affect us all. The Northwest Passage Project was born at the University of Rhode Island Graduate School of Oceanography by a team led by principal investigator and project director, Gail Scowcroft. The project's novel approach to ocean science research and communication is to include a diverse group of 28 undergraduate and graduate science majors from around the United States who will work alongside scientists. The expedition team gathers in Newburgh, New York for a final briefing.
This is a historic cruise that will hopefully provide very important pieces of the climate change puzzle to the world. You all deserve a round of applause.
Having few roads or airports, the Arctic is not easy to reach. An Air National Guard cargo plane transports the team, along with thousands of pounds of science instruments, from Newburgh to Thule, Greenland. For the students, selected from a large competitive group of candidates, this is a once-in-a-lifetime opportunity.
I'm in Chicago, right? So we don't have an ocean or anything, and I wanted to do marine biology research, but this is like huge. You know, nobody gets to do this, you know, and go on like a research expedition as an undergrad.
Getting accepted was probably one of the best days of my life. I just started checking my emails like every hour all of a sudden. Congratulations, you got accepted. And it was surreal.
It's really just completely out of my comfort zone. Wow, like how did I get here? You know, this little girl who once wanted to study marine science, you know, from Florida is now in the Arctic.
This place is changing more than any other place in the world due to climate change.
We need more effort going into the Arctic and understanding what's actually happening here, the dynamics of climate change.
In Thule, they board the Swedish icebreaker Oden. Two of the participants are Inuit young professionals who live in the Arctic region called Nunavut. None of the other students have been to the Arctic, and no one has been on a research vessel before.
Growing up in Nunavut, you hear so many stories about the Northwest Passage. For me to be able to sail the Northwest Passage is amazing. This is just beyond words for me.
The 350-foot Oden's ice-breaking abilities make her one of the world's most capable polar research vessels. From Thule, Greenland, the ship heads west across Baffin Bay towards Lancaster Sound and into the waterway that traverses the Canadian Arctic, called the Northwest Passage. Bryce Luce from the University of Rhode Island Graduate School of Oceanography is the chief scientist. He's a veteran of several Arctic research trips, but never with so many students.
We've entered into this era called the New Arctic. That's what we refer to it as, and that ice cover retreats for much longer of the year, and ice cover is often much thinner. And so we can venture in, we can stay longer, we can conduct more detailed examinations. We're here with these multifaceted goals in mind. So we have, groups studying chemistry, we have groups studying microbiology, we have groups focused on birds and mammals, and we have groups focusing on the physical oceanography. So we have the opportunity here to come in and characterize this area, which has gone through quite a tremendous change in the last 5 to 10 years. We can start to highlight the changes that may be taking place. All of that will keep us going 7 days a week, 24 hours a day for this entire 18-day cruise so that we can make the most of every single moment that the ship provides us.
Holly Morin, also from the URI Graduate School of Oceanography, is a marine mammal scientist. She is the expedition coordinator for the students and will be hosting live satellite broadcasts from the ship to museums in the U.S.
I'm charged with managing all the students, making sure that they know what they need to be doing, that they're all safe, that they're all feeling well, they're getting rest, but that the research is being able to be conducted and coordinated as necessary, that the broadcasts are happening, that the students are doing their blogs, all those different activities I'm kind of keeping track of.
Will eventually be leaving the boat, one way or the
Much will be expected of them. Beyond a rigorous around-the-clock research schedule, the students will be participating in dozens of live broadcasts.
They're all amazing. I feel very blessed to be with this group of students that are all motivated, so aware of their environment and the changes that are happening. A typical day for the students, they may have been up the night before until midnight, or they could have been waking up at midnight, that's when the shifts change, to pick up where the other team left off. If they are off, then they can sleep, they can rest, work on their journals. I want to make sure that they're getting the most out of this expedition, that they're learning, and that excitement they had on that first day is not waning.
I always dreamt about going through the Northwest Passage as a little boy. Here I am now. It makes me very happy. My great-grandfather was a sailor. He gone through the Northwest Passage. I want to follow his footprints. These waters are very important to us because we hunt a lot of the marine mammals. In our community, we are very concerned that in a couple years that there's going to be a lot of ships coming through here, and we're scared that we'll have a lot of oil spills and it's going to ruin our marine mammals.
We think about climate change all the time, our generation. Definitely me and my friends back home, or even all of us here on the ship, we feel like it's something our generation has to solve. We wish people would listen to us more about it.
Ed Struzik's been thinking and writing about climate issues for decades. a Canadian author, lecturer, and journalist with over 40 years of experience reporting on the Arctic, Ed's recent book, Future Arctic, details the many changes he has witnessed here.
And I'm hoping that this is going to give you a bit of perspective about what you're doing here. Now that the Arctic is warming, what's happening? Well, you know the story. Sea ice is melting, glaciers are thinning, sea levels are rising. The old Arctic, as I knew it 40 years ago, is disappearing very quickly, and a new Arctic is emerging. You know, we're seeing sea ice retreating, glaciers melting, permafrost thawing. We're seeing some communities like Tuktoyaktuk and Shishmaref, you know, literally falling into the sea. I'm absolutely astonished by it. Climate change is really the main factor. You know, temperatures have risen here twice as fast as they have in any other place in the world. The melting of the glaciers is a monumental problem. All that ice that we have on the Greenland ice cap is going to raise seawater levels by, you know, not inches, but by feet and yards. That's going to impact low-lying coastal communities in the Western Arctic right into Siberia, but it's also going to affect, you know, places like Miami, Louisiana, look at New Orleans. So this is a global problem.
When you're on a vessel that costs roughly $7,000 an hour to operate, $170,000 a day, you try to take advantage of every single moment that exists. So we operate the vessel, scientifically speaking, 24 hours a day, 7 days a week. So there are no weekends, there are no holidays. Oceanographers have a lot of different tools that they use to observe the ocean. However, probably the CTD Rosette package is the one that's the most widely used and considered kind of like the gold standard.
The CTD, meaning conductivity, temperature, depth, measures the physical properties of seawater. This data is key to understanding the physics, chemistry, and biology of the water column at various depths. The critical CTD will be deployed over 50 times throughout the expedition.
All over the world, there are boats using instruments just like this. It's a combination of electronic measurement equipment, basically, that instrument down below. It will measure temperature, conductivity, fluorescence, and that is paired with this 24-bottle rosette. Each bottle is called a Niskin. Just as we have 24 bottles, we have 24 of these release teeth. When we send it over at the beginning, each Niskin is opened up so that you can have free passage of water through each bottle.
I need help with this one. Thank you.
Yeah, no problem.
Do you want to check all the valves? Water's over there.
Thank you.
The water sampling equipment that we send over the side, it can weigh as much as 2 tons. They're out there with hard hats, like able-bodied seamen. These are all new experiences for them, and we just want to make sure that they're getting as much out of it as they can.
Water samples from the CTD can identify the amount of glacier ice melt, measure the release of trapped greenhouse gases, and survey the diversity of organisms in the water.
What happens is kind of an intricate dance. Many people want to have access to this water, and there's sort of an order of operations.
But if we want to go ahead with 11, nobody else has to. This was the best kind of educational experience it could have been, in the sense of there was a lot of independence with it. If Plankton hasn't already taken 17, you guys can try 17. But ask them if they've used it. It was really on you to do things properly and to get questions answered if you needed to.
So just to be clear, for my brain, one station is just going to go down and we're going to get the data.
And then the next station, we're gonna get the water samples?
Yes.
Now we're just flip-flop between.
But the bottles still have to be caulked when they go there. As a chief scientist, it's my responsibility to make sure that we accomplish as much as we can, scientifically speaking, but this project is novel in the sense that we've got such a large contingent of really basically early career undergraduate researchers. This is their first time doing oceanography. They're just confronted with all these new circumstances that can be quite kind of overwhelming, frankly.
2-micron filter.
The excitement of working with people who are doing this for the first time reminds you how it was for you when you did it for the first time, and that's really nice.
It's something that I never thought I'd want to do. I just wanted to see if this would interest me, and now I'm pretty sure that this is something that I want to do for the rest of my life.
Oh my God.
No way!
I'm a city boy. All I see is skyscrapers every day, and coming out here, seeing this isolated area is just, it's peaceful, it's serene, it's tranquil.
My understanding is that we're meeting in the mess hall area.
Maybe I told my guys to go take a look at the schedule. And
Don Glygon is a physical oceanographer from the Virginia Institute of Marine Science.
Not sure if it's tour. Do you have,
He has been studying Arctic water circulation and its impact on climate and ecosystems for years. He returns here as often as he can.
Going to sea is always an exciting experience, but coming to here with the students and sharing that experience with them, it's really, really unique. And this location, it's remarkable. We're doing really good science. The data we're collecting is high quality, and we're hitting the stations that we need to hit. So this is, so far, has been a very successful mission.
The ever-changing seascape of Arctic ice is stunningly beautiful and mesmerizing to watch. Ice was perilous to early sailors who ventured here, but now it is vital to protect our warming planet. And for Don Gly, it's a critical subject for research.
How important is ice to our ecosystem? So of course it's important to the species and the organisms in the Arctic. At the same time, changes in the Arctic, which will lead to climate and weather pattern changes at lower latitude, will also change their ecosystem. The ice, as you can see, the color is white, and it reflects most of the sunlight coming to the surface. So when that happens, the solar energy is now absorbed by Earth. It's reflected back to space. However, when ice disappears, then you can see in the ocean behind us, it's a deeper blue color. And that darker color absorbs the solar energy and makes the water heat up, and that retains that heat in the atmosphere and in the ocean. So the warming of the Arctic can potentially affect the weather, in lower latitude days from now or next week.
The Northwest Passage, which is part of the Canadian Arctic Archipelago, is essentially a connection between two major ocean basins. You have the Arctic Ocean and the Atlantic Ocean. The Western Arctic supplies a large quantity of fresh water flowing through the archipelago into Baffin Bay and into the Atlantic. The reason why that matters is that the fresh water tends to be buoyant, stay on top, and when it comes out of the Arctic and Baffin Bay, it's going to hug the coast, right along the coast of Canada and eventually makes its way down to the U.S. East Coast. So to understand the exchange, how much water is moving through, what kind of water, how much heat, how much fresh water, we got to measure the water properties as well as the circulation in this region.
I'm a graduate student, a PhD student, co-leading the physical oceanography team here. We're particularly interested in identifying the origin and the circulation of the water masses that are passing through the Northwest Passage.
We are also playing around with robotics and seeing what kind of imagery we can collect in the air and under the water. How is this particular area changing related to climate change?
A remotely operated vehicle is used to observe the underside of the ice, to assess its condition and age, and determine the presence of algae growing on it.
Watch your depth change. So you're gonna go up like what?
Most of the Canadian Arctic Archipelago we're passing through is part of Canada's northernmost territory called Nunavut. About 65,000 Indigenous Inuit live here, in one of the world's most remote and sparsely settled regions.
Inuit are the original Arctic researchers. We've been here for thousands of years. We've made observations.
Our itinerary for the next 2 days. We'll go to Pond Inlet, you'll see in the evening tomorrow. They want to know about what we're doing, and we want to know about what they're doing. Here you go.
I'm from Cambridge Bay, Nunavut.
We have Inuit values, 8 Inuit values, all summed up into a word, which is, and it would be funny to get you guys to say it, Inuit, and then the second word is another word, Kauyi Maya Tukangi. All right. After me, okay. Inuit, Kauyi Maya Tukangi. Yeah.
Traditional Inuit knowledge and science and research don't have to be two separate things. We can work together easily and in a more beneficial way for both sides.
Few towns in Nunavut have docks and must be reached by small boat or helicopter. With a population of about 1,600, Pond Inlet is one of the larger Inuit communities.
Okay, next please.
What about me? Should start with the meat first, huh?
Alex Anavapik is a lifelong resident of Pond Inlet. An artist and local youth mentor, she also joins cruise ships as a culture guide.
Even though the north is very wild and just very vast, desolate, but if you look close enough, there's beautiful life. And that the culture is rich. There's still amazing things to be discovered. It's interesting trying to see the changes that's happening from a local perspective. Ever since I was a little kid, I've seen glaciers, and every year I've been seeing them recede. Being able to see really odd weather changes, like this fog right here. Sometimes it just gets a little too warm, sometimes it gets a little too windy. Pond Inlet is not known for wind. So I've noticed changes. But the question is, how can we change it? It's not just the polar bear's home, it's also my home.
Kaya ka tiyangin na maawayang ima. Kaya ka leo tibig sa nerono na. Suna ubare na kakuduguro. My father, my mom, they were both carvers, and my grandfather. There's lots of stories to this as I could look. This is what made us alive today.
Kudlik lamps are carved from stone. Fueled by whale or seal oil, they were an essential part of Inuit life for centuries, to warm igloos, for cooking and light.
We got one.
Today, their flames burn mostly to keep the memory of this tradition alive.
I grew up out on the land, hunter, carver. I've been carving ever since when I was 18-year-old. This is my job. I love it.
Keeping traditions and culture is important to the Inuit, but it hasn't always been easy. In the 1950s, in an effort to extend their sovereignty, the Canadian government relocated Inuit families to the extreme high Arctic areas of Resolute and Grise Fiord. In Resolute Bay today, a proud Inuk looks northward. Hundreds of miles away in Grise Fiord, an exiled mother and child look to the south. Monuments in remembrance of these injustices. They've faced great hardships, but have always survived by being one with the land.
Even if the ice did go away, we would still adapt as people. We always adapt.
I love that.
Beneath a sea of broken ice is another important focus of study: the unseen creatures that dwell in the water column and are vulnerable to a changing climate. Graduate student Jacob Strock co-leads the microbiology team on the expedition.
We're studying the microscopic communities. When most people come to a region like this, they might think about the whales or the walrus or bears, all the big things out there. But really, these ecosystems depend on the microscopic members. Phytoplankton and microzooplankton. Phytoplankton, although most people may have never seen one before, most of these organisms are microscopic, play an important role, not just in the Arctic, but in a global sense. They feed most of the food web. They take up carbon dioxide in the surface waters, at which point they may die, be consumed, and by many forms, be transported into the deep ocean.
Data on plankton from this region is scarce, so the first goal is to identify what's here. Plankton communities are quite sensitive to their environment, so the microbiology team wants to know how they're being affected by warming waters and increased freshwater from ice melt.
The flow cam is one of our critical instruments on this trip. If it sees the excitation of pigments in the plankton, it will know to take a picture, and it will pop up on our computer screen, and we can see what types of plankton we're seeing in the water, how abundant they are, and altogether, what the communities look like across these very diverse habitats that we've been passing through on our cruise. We're just trying to understand how the Arctic is functioning now, let alone how, in a changing environment, what the future might look like.
So you're going to put them in the bins?
We're going to put them in the bins. We're going to put them in our light treatment bags. To check.
I can't believe it. I wonder what I did to be able to deserve seeing such beauty and experience all this scientific knowledge. And I'm on board with so many smart individuals who are just willing to just share all the information they have. It's amazing. I plan on getting my master's in secondary education. I want to be a high school teacher. It'd be important to me to be able to help the next generation.
While there may be less of it, sea ice remains the key to understanding ocean processes in the Arctic.
I think we have this one
By analyzing sea ice cores, scientists can measure methane, carbon dioxide, plankton, and more. But first, you must find a piece of ice large enough to support a helicopter, which can be a surreal experience for newbies.
This is crazy. We're in the middle of the ocean.
It's never not a bad idea to fly the pilot again.
Pull this out. Pull this one out.
Wow. Water underneath you.
You're walking that far up.
I know. You're good. You're good. I'm standing up here.
Walked out. Wow, we are on the ocean.
Pretty salty.
Is it?
Is it magically delicious?
Yeah, it's just seawater.
Let's start with
I think the reality is that all of the first year ice is so melted and rotten by this point that the only thing left to stand on is multi-year ice. So you just basically try to keep it straight up and down, and we'll see how it goes. It's going to... Oh, nice.
Man.
So am I putting this in the hole over there?
You can see the bottom has kind of like a polished look. Maybe there was some refreezing. This is definitely a second-year ice core, though, because you can see how rotten it is. So there's some really big holes and other like drainage pockets here. We'd use the top as 0.
Right,
And basically, Kevin's going to come from that side, and you can just kneel down, and you're going to just score the ice at the 10-centimeter point. All right. That's good. Okay, that's perfect. That's enough of a score. So then, Morelli, you'll come. Kevin's going to work his way this way, and you will drill a hole it.
Does it go all the way through?
It's just, yeah, go down as deep as it goes. Yeah, perfect. So.
1.8.
Okay. This is the nicest the Arctic has ever been when I was in it. Like, it's usually cloudy. Every 10 days, the temperature drops to -10. And yeah, it feels a lot more like the Arctic. What about you? Is this typical for this time of year?
In the last 5 years, it's been, a crazy hot summer and a really cold winter, or like it's been like up and down.
You never know what you're gonna
It's
get.
unexpected.
Yeah.
It's all unexpected.
When organic matter decays in the sea or in the permafrost, where there is little oxygen, some of it is transformed into methane, a key greenhouse gas responsible for global warming. Much of that methane is bound up in the frozen layers of Arctic soil and seabed.
If that methane makes it to the atmosphere, we will have a much more intensive warming than what we have seen up until this point. And the quantities that are in the Arctic are vast, and so that's concerning.
By measuring methane concentrations in the ice back in the lab, Bryce and team can look for evidence that bacteria are consuming this potent greenhouse gas before it can escape into the atmosphere.
Oh man, that was scary and crazy, but awesome.
The primary goal of taking ice samples was to measure the concentration of greenhouse gases. But locked within this ice was another disturbing find.
For a long time, it's been known that the problem of plastic in the ocean is a large and growing one. The fibers of our synthetic blankets, our synthetic clothing, when they shed, like any natural fiber does, that doesn't break down and that gets into the environment. As well as companies were putting these micro beads, essentially exfoliating beads that you put in body wash, and those will go straight into the water and then out into the ocean. So we're starting to see the legacy of all that.
Much more clear. This one. This is an ice core from multi-year ice, and we can see a lot of fibers, blue and black ones. And also we see small filaments of other kind of colors.
Yeah.
Transparent. So this is microplastic, of course. You can see the shape and the size also.
Yeah, I'm seeing a lot more blue specks, like.
Say this blue stuff.
There was so much plastic that you could look at it with your naked eye and just see all of the beads and the fibers and the filaments sitting there in the bottom of the container.
Here it's very clear that there is the presence of multi-beam, because I think they,
there too, right?
Yeah, also here. And I think
Microplastics have been documented in the Central Arctic, but this is the first time they've been found in the high Arctic.
I was never expecting this amount and this variety of plastic, so it's incredible. We didn't expect this. It was completely shocking.
Even knowing what we knew about the occurrence of plastic in ice, it was kind of a punch to the stomach to see what looked like a normal sea ice core in such a beautiful, pristine environment, but just chock full of this material, which is completely foreign to the environment.
Finding a Northwest Passage through the Arctic, a northern water shortcut between the Atlantic and Pacific, had been the obsessive quest of explorers and navies for centuries. Scores of ships sailed into the Arctic, their crews enduring long winter months of total darkness in sub-zero temperatures, with their ships frozen in the ice. Sailors succumbed to exposure, scurvy, starvation, insanity, even death. Stout wooden ships were crushed like matchboxes by the ice. In 1845, British explorer Sir John Franklin and his two ships, HMS Terror and Erebus, mysteriously vanished while searching for the Northwest Passage. British naval officer Sir Francis McClintock led one of dozens of searches to find them. From 1857 to 1859, they traveled by water and land. When they reached Bellot Strait, it was blocked by ice. Before retreating, they built this stone cairn as a signpost to others. During his search, McClintock found the last known letter from the Franklin expedition inside a cairn. Dated May 1847, it says all is well, with Franklin in command. A second message, added 11 months later, reports their ships deserted after being trapped in ice, and 24 crew were dead, including Franklin. Though much of Franklin's demise is still a mystery, we do know that his ships overwintered at a place called Beechey Island.
Welcome to Beechey Island. This is one of the most historic as far as the Franklin expedition and the search for the Northwest Passage. So just a reminder, everything here could be historic. There's still tons of stuff they haven't found. So we just don't want to pick up any pieces of wood, any pieces of bone, anything at all. Just leave everything here intact because there's still archaeological work being done and the diehards are still looking for Franklin, so we don't want to miss any clues. So we're gonna walk towards the grave sites. We can always cut down by the shoreline and walk by the ice. Okay, let's do that.
It's 1845. Franklin's two ships, the Erebus and the Terror, have sailed from England and are attempting to sail through the Northwest Passage. There are 129 men aboard. They are sailing through Lancaster Sound, where we have made our own transit. The plan had been to sail farther west before overwintering, but the ice was increasing. This is clearly a calm harbor, and so it's presumed that for that reason, Franklin anchored the Erebus and the Terror in this bay and then camped there for the winter. On what you can see is one of the bleaker spots you can imagine. There's no visible vegetation. There's no sign that animals are around here in any kind of numbers. This is a brutal place to be. There are 4 graves here. One of them is from somebody who died later on a Franklin search mission. But the 3 men who are buried here were young common seamen. It had been presumed for many, many decades that they may have died of lead poisoning. For one of the first times an expedition was using tinned food, tin cans of meat that had been soldered together with lead. And so these graves were exhumed in the 1980s to test for lead levels.
Because these were such shallow graves and because of how cold it is, the men, like they took out Torrington, he looked perfectly preserved. He honestly looked like he just fell asleep.
It's all intact. They don't look like bodies that are almost 150 years old at the point at which those photographs were taken. The kind of exposure that they had, poor nutrition, weakened their systems to the extent that they were more susceptible to diseases. John Torrington died of pneumonia, for example. Out of 129 men, to lose 3 is not great, but it's not catastrophic at this point. So by the time the Franklin expedition leaves Beechey Island, it's in relatively okay shape. And at that point, they kind of drop off the map. For years and years afterward, search expeditions would come here. There were 40 of these expeditions in the first 15 years the expedition went missing alone. Many of the British and American searchers encounter Inuit who said, yeah, we saw the ships and the guys. They were heading south and they were starving and they were eating each other.
And cannibalism. And John Ray brought that back to Victorian England, and it was a huge scandal. They just weren't willing to believe what we now know is true. You know, by the end, they find skeletons under boats and lying on the shore and everything, you know, people dying where they fell. It's very harsh up here. Anybody want to spend a winter up here? What do you think?
What a place to die. I've spent a lot of years trying to dispel one of the myths about the Arctic, which is that it's a barren and blank place. Talking about how rich the human culture is, how rich the megafauna and the microfauna is, in a region that is not easy to live in, but is still richly alive. And then I look around Beechey Island, and I think, this is a really bleak and barren place. This is really hostile to human life.
In 2014, Franklin's ship, Erebus, was finally found near King William Island, a few hundred miles south of here, 168 years after its loss. In 2016, the Terror was located nearby, solving one of the Arctic's greatest maritime mysteries. Not all Arctic wildlife is obvious. Sarah, Osa, and Ed motor into Cunningham Inlet on Somerset Island. They hope to see the North's iconic white whales, belugas.
I spent time at the Vancouver Aquarium volunteering with beluga whales, and they're so social and gentle. I just love them. Such personalities.
We're only seeing a little microcosm of, of what's actually happening here. They could be having a good laugh someplace else, maybe a few hundred meters away.
This protected inlet is a summer gathering spot where belugas mate and care for their young. On a good day, hundreds can be seen here.
It is pretty cool when you see the big aggregations of them, and they just seem to be having a ball,
Yeah.
One of the theories is that this is kind of like a reunion of families.
Makes sense?
Yeah, entirely possible.
See if we can hear these, Ed. See if there's any in the neighborhood.
Belugas have been called sea canaries for their high-pitched, bird-like calls.
Oh, I hear it now. Oh. That's so cool.
There. They're really communicating. Oh, really cool.
So good.
The belugas remain elusive, but 3 days later, Sarah and Ed have another chance to see them from the shores of Elwyn Bay, also on Somerset Island. Sadly, the ground here is littered with the bones of a terrible legacy.
Looks like we have some vertebrae here.
Yep, the skull.
Pieces of skull and jaw bones.
Yeah, it's on both sides of this big beach here. This goes on forever.
Pretty small animals here.
Yeah, poor little cows.
Being here is such a terrible reminder of what humans used for lighting fuel before fossil fuels. They boiled whales, and this is evidence.
Yeah, and they came all the way across the ocean here to slaughter thousands of them. It just must have been, an awful scene.
Just a massacre.
From 1874 to 1898, dozens of whaling ships from Scotland and England hunted belugas here. In what was called a drive fishery, the whalers used boats to drive the timid belugas into the shallow end of the bay. And when grounded at low tide, they were slaughtered with lances. It's said that the blubber from every 6 to 7 whales would produce a ton of oil. More than 10,000 perished here. Beluga migration patterns seem unchanged since the 19th century. No longer hunted commercially, it's been estimated that over 100,000 swim in Canadian waters today. That these pure white whales continue to thrive in places like Elwyn Bay as they tenderly escort their dark-skinned young is a hopeful sign that the Arctic, too, will endure. The whalers are gone, but they've been replaced with new threats to Arctic life. Naval submarines conduct training exercises in the Beaufort Sea. Several Arctic countries operate ice-breaking warships. Canada has built a new class of Arctic patrol vessel. The world is paying more attention to this once isolated region. Transiting the Northwest Passage cuts the travel time between Europe and Asia by 40%. A container ship sailing from Shanghai through the passage to New York can save up to $2 million on fuel and fees each way, compared with the southern route via the Panama Canal. The first ice-breaking cargo ship transited the Northwest Passage in 2014, and more are sure to follow. Ore carriers regularly transit the passage in summer. And cruise ship traffic is increasing. Everyone wants to see the frozen Arctic, while the ice is still here. But with more ship traffic comes greater risks.
We've already started to see some commercial traffic. It's a matter of time, I think, that before we do have an accident. We have no establishment in the Arctic for a cleanup operation. The problem is that the rescue is so far away. We don't have any search and rescue operations that are based in the Arctic outside of, Alaska or Greenland.
What I love are places that resist human imprints. Part of what is so heartbreaking about the state of the Arctic right now is that those human processes that couldn't touch it in the past are touching it in the form of climate change. That kind of human impact, it's heartbreaking and enraging.
I think we're in a lot of trouble. The old Arctic is disappearing and a new Arctic is unfolding in a really dramatic way. And it's quite astonishing to see how it has been progressing.
I would say a little pessimistic. I'm very worried. I'm worried about too much of a changing Arctic. It's pretty scary. It's pretty scary to me.
I'm concerned about that the ice. It doesn't have the chance to build up this multi-year ice that we have seen before. So I don't know if it's temperature or if the weather that makes it like that, but it's a total climate change anyway that we cannot deny.
I try to maintain a composure that is sort of befitting of a scientist to keep the emotion out of it, but I feel like we're watching a slow-moving tragedy unfold in front of us. These young people are all here. They are acutely aware of what's coming. It kind of makes me want to cry because there isn't the political will, there isn't the organization. If there is anybody to record this, the future, they will probably condemn us for our shortcomings, and rightly so, for not having completed the task that was in front of us.
Anthropogenic climate change will not allow for short-term solutions. And what I see in the students today is not just an energy about the problem, but a sense of the kind of sweep of timeline, that this is the problem not just of their generation, but of their lifetime.
For our generation, climate change is causing a lot of anxiety. We hear everything from all different sources. So I think since we're more exposed to that, I feel like we're more vulnerable and we have to do something about it.
Science has a really big role to play. So I think it's really, really important to get the young people out and experiencing the polar regions and also getting into the science. It's the future.
We've got to have more and more expeditions like this, combining scientific research and education to appeal to the people down south, to make them understand that what happens in the Arctic, for example, matters to them and to the rest of the world.
it's a very isolated area, but once you come actually and see it, I think you change as a person. You see that there has to be something done. It has to be preserved. The more we advocate about Arctic research and preservation, I think the more people open their eyes and realize that something has to be done, or else it's going to be irreversible.
The rate of change is unprecedented in human history. It's critical that we capture that change. The baseline is always changing. If each generation of scientists come here and thinking, okay, this is normal, this is how it is, then we will have failed. We will have missed the boat. If we don't capture this today, then 10, 20, or 50 years from now, nobody will remember this. This will be all gone. We have that sense of responsibility for taking care of our planet today and sharing what we see, this beautiful place, this beautiful planet, with future generations.